in this section, we're going to talk about the concept of conditional probability. And that's going to hinge upon two main questions. Well, that's actually one question. You just have to decide which one it is. Just, is the event you're talking about independent, or is it dependent? And what that means is pretty simple to is similar to what you would just say in your standard everyday language. Just if something is independent, it means it does not depend on anything else. It means it stands on its own. So whatever happened before does not affect it now. Where a dependent event is the opposite. So they're saying that what happened before does affect its outcome or its likelihood or something of that nature. So if first a meteor fell from the sky, then that's going to change the likelihood of me getting some kind of radiation. I don't know, that was just random, but there you go. Okay, so the formula we're going to use here is this one right here. This is going to be an important formula. And what we're going to talk about here is there's a little bit of notation I got to point out here. But what this is saying here is this is the formula for the conditional probabilities. And this right here, this bar, means given that. So what we're going to say here is the probability, so looking at this part right here, the probability of A and B happening, the likelihood of both A and B occurring, is equal to the probability of A occurring times the probability of B occurring, given that A has already happened. So that's what it means, right? So we're asking, what is the probability? That's the question. The first part here is the question. We're saying, what is the likelihood of that happening, given that we already know that happened? The meteor struck the Earth. What's the likelihood of me getting radiation poisoning? Something like that. And we're going to take this equation and we can manipulate it. It has an equal sign. So if, for example, you could also do something like this. The probability of B given A is equal to the probability of A intersect B divided by the probability of A. Right? You can play any kind of game just depending on the information that is given to kind of calculate what you need, given what you have. So let's see here. Now, so for example, let me just give you an example of something that is not independent, something that is independent, something that is not dependent, and that'd be like flipping a coin, right? So if I flip one coin, it helps if you spell it right, twice. What's the probability of me getting a heads on the first flip? Well, so the probability of me getting a heads on the first flip, well, we all know that's 1/2. Now, what's the probability of me getting a tails on the second flip? Well, again, that's 1/2. It didn't matter. Now, it doesn't matter though. What if I asked you this? What's the probability of me getting a tails given that my first flip was a heads? Well, again, it doesn't matter because they are independent. The flip of the second flip does not matter whatever the flip that came before it was. So therefore, what we're going to say here is there is this little thing called a test for independence, and this is really kind of common sense. It just says an event is independent if the probability of, like, whoops, well, let's just do it this way. The probability of A given B, so saying what's the probability of A happening given B already happened, is equal to the probability of just A happening regardless of B happening or not happening. So this statement, if this is true, then it means they're independent. The fact that B happened does not affect A. And the letters are arbitrary. If you wanted to flip them around, you can make it B given A, B, something like that. It doesn't matter which order they're in. It's just saying what's the likelihood of something happening given A already happened. Well, if that's equal to just the likelihood of that thing happening regardless, then it is independent. Okay, so let's try our first problem. Yeah, by the way, that's kind of the whole lesson, the big ideas. So now we're just going to use them, and I'm just going to try to get you comfortable with the with doing some of these problems. So when flipping one coin twice, what is the probability of getting a heads then a tails? Okay. Now this is our first time seeing something like this, but notice it's kind of going to kind of be like this up here. What we're going to say is like how we're going to look at this is we're going to kind of say like, all right, it's like the probability of A. Well, so A is getting a heads, right? And we also need to get a tails. But the order is important. We're saying that you first have to get heads, then you have to get tails. So if I flip my coin and I first get a tails, I'm out. I lose. That's it, right? You lose because it says you have to get a heads, then a tails. Okay, so the order here is kind of important. So what we're going to say here is, well, first I can just start off by saying, what's the likelihood of me getting a heads on my first flip, right? What's my chances of that happening? Then times, and I'll talk about why that's times in a second. What's the probability of me getting a tails given that I just got a heads? See, there's that formula. It's kind of just logical, except, and we'll talk about should this be times or plus in just a second. Let's just do these probabilities. So the first one, probability of me getting a heads, that's 1/2. Now times or plus or whatever it may be, the probability of me getting a tails, given that I just got a heads. Well, like we just talked about up here, it doesn't matter, right? The likelihood of me getting a tails isn't affected by the fact that I already got a heads. So it's the same as just the probability of me getting a tails. So therefore, that's 1/2. So 1/2 times 1/2 equals 1/4. And clearly, it can't be plus because 1/2 plus 1/2 would make 1. And the likelihood of me getting a heads then a tails is not 100%, right? Okay. And what I want you to ask yourself, anytime you look at a problem and you're trying to decide, is it adding or is it multiplying? Well, ask yourself, is it making it easier to win or harder to win? If the probability of me getting heads was already 1/2 and now I have to get a tails after that, that makes it harder for me to win. I didn't automatically win just by just getting my heads. So therefore, it has to be a multiplication, because when we multiply by decimals, that number gets smaller, meaning the likelihood of me winning gets lower. If it was addition, that means a decimal plus a decimal makes a bigger decimal, right? Makes a bigger number. So that's not what we want in this scenario. All right, so that's kind of one way to identify the difference here between multiplication and addition, is just say, is it getting more likely for me to win, or is the rules getting harder for me to win? Okay, now we can also verify this just by very quickly. Let's write out all the possible scenarios, right? I could get a heads and a heads, or heads and a tails, and a tails and a heads, and try again, or a tails and a tails, right? Now, out of these 4 possibilities, what is the one winning scenario? Well, I had to get a heads, then a tails. So you'll see there's 1 out of the 4 possibilities gives me this scenario. Okay, so this is an example of, again, it's still a conditional probability, but the events were independent. They were not dependent. So you kind of just look at them as 2 separate it's 2 separate probability problems. Multiply them together, and you're done. Not too bad. Okay, now this one's gonna be fun. All right, a bag of marbles, because everybody loves marbles, right? This is your favorite. When next time you go to the store or go to the Phoenix Zoo and you see that little bag where you can put all the little rocks or marbles, I do not want you to have any night terrors. I don't want you to have any scary moments there where you're going to kind of black out and say probability and run out of the room screaming. Okay. All right, so a bag of marbles has 3 blue, 5 yellow, 2 red, 1 pink, and 6 green marbles in them. Okay. We are going to pull 5 marbles from the bag. I want you to calculate the probability of us getting 1 pink and all the reds. Okay. Now this first problem requires nothing new. This is just our old techniques. Okay, this is just our old techniques. So can you do this? Can you calculate the probability of getting 1 pink and all the reds? Okay, so here we go. The probability of getting 1 pink and all the reds. Well, take care of your condition first, right? Well, actually, first, just start with your denominator or your numerator. Denominator seems relatively easy because it's just how many marbles are in the bag. Well, it's 5, 8, 9, 10, 11, 17. So out of the 17 marbles, we're going to pick 5. Order does not matter. Okay, so then, now take care of your condition first. We need to get 1 pink. We're going to guarantee 1 pink. So out of the 1 pink, we're going to choose 1 pink. Right, that takes care of the pinks. This guarantees the pinks. Now, let's guarantee the reds. Let's see, how many reds are there? There are 2 reds, and we need all of them. Okay, so out of the 2 reds, I'm going to choose all 2 of them. So that right there takes care of all the reds. So now I have taken care of my condition. So now I need to fill in the rest of my hand, because we've only picked out 3 marbles, and we needed a total of 5. So it means I need 2 more. So let's see, how many marbles are left that are not pink nor red? Well, we just took out 3, so that leaves us with, what, 14? So out of the 14 other marbles, I need to pick 2 more. And there we go. So that would be our probability of picking 1 pink and all the reds. So if we reach in, pull 5 marbles, it's going to be 14 combinations, 2 over 17 combinations, 5. Okay, now, separate problem. Same bag of marbles, but what's the probability of me getting the 1 pink? Just the 1 pink. Okay, so take care of your condition first. So get out of the 1 pink, choose the 1 pink, right? Then that's all I got. So therefore, now I'm just going to do how many marbles are left in the bag? 16, and out of those I need to choose 4 over the same 17, choose 5. 17 combinations, 5. Okay, here we go again. Next problem. What is the probability of getting all the red given you already have 1 pink? All right, now this is kind of new, so I want you to think about this for a minute. It's really kind of logical. Okay. Now, when we say given that you have 1 pink, what is important for you to understand is that it's already happened. It's like you're walking up to the middle of the game and the person has already pulled 1 marble out of the bag and it's pink and they've got 4 more to go. So once you understand that, you say, okay, well, then this problem is really quite similar to that, right? It's really similar. Just so now we're going to take care of our condition. We want them to get all the reds. So out of the 2 reds, we're going to force 2 of them into their hands. Then there are, again, 14 marbles left in the bag. So do you see it's kind of like a combination of both these problems? And then out of the 14 marbles, I need to choose 2 out, not 3. 2, because the person needs a total of 5 marbles. This right here is going to give them 2 other marbles. This gave them 2 red marbles, 2 and 2. I know we all can do this. That makes 4. But you have to remember, they already have 1 marble in their hand, which makes 5. All right, so therefore, now the denominator. What is my denominator going to be? There are not 17 marbles in the bag anymore because they've already chosen 1 out. So there are actually only 16 marbles left in the bag. And out of those, we still need to pick 4 because they already have 1 in their hand. So that's the trick to conditional probabilities, is once you kind of just get the idea that something's already happened, the numbers actually get smaller. Everything gets simpler. And so it's not so bad. So anyway, so this is going to leave us with 14 combinations 2 over 16 combinations 4 because 2C2 is 1. All right, so now what I want to do is the conditional probability formula from up above says the probability of A and B occurring is equal to the probability of A times the probability of B given A. So this is what we just did. I just broke it up into 3 separate problems. So you'll see part A is the probability of A and B occurring. And we know that answer was 14 combinations. What did we end up with? 14 combinations 2? Yeah. 2? Yeah. Over 17 combinations 5. Now, the probability of A, just the probability. So I chose A to be getting a pink. And you could have done the other way. You could have started with the getting all reds, then given that you had all the reds, now what's the probability of you getting 1 pink? It doesn't matter the order you go in. So just pick 1. So I just wrote it out this way. So the probability of us getting a pink just simplifies out to be 16C4 over 17C5 times the probability of us ending up with the 1 pink would be 14 combinations 2 divided by 16 combinations 4. And so now you can see that divides with that, leaving me with, wow, look at that. That's kind of crazy. 14 combinations 2 divided by 17 combinations 5. So that probability could be figured out. The probability of both A and B occurring, the probability of me getting all the reds and the 1 pink can be calculated by me simply just saying what's the probability of me getting 1 pink, figuring out all those probabilities, or all those combinations, then finding out, right, given that I already had the 1 pink, what's the probability of me getting all the reds, and taking those 2 values and multiplying. And again, be prepared. We're going to ask you not to do it always in that method, but we will ask you to kind of manipulate them around, right? So just be prepared. Maybe sometimes you'll divide and you'll say, what is the, I want to know the probability of B given A, and I don't have the ability to figure that out, but the book told me these two values. They told me A and B, and they told me just A, so I can divide them and get the other one. So just be prepared. That formula is going to be needed. So this is a good stopping point. This is a good stopping point because the rest of this at this point is just practice. So I'll see you in the next video.